Welcome to today's Explainer. Okay, let's dive right into this because we've got a seriously fascinating topic on our hands. Today, we're looking at how cutting-edge technology, specifically the Internet of Things, can actually point us toward a surprisingly simple, real-world fix to drastically reduce urban pollution. We hear the buzzword smart cities all the time, right? Well, today, we're going to look at what smart mobility actually looks like on the ground and how combining high-tech data with minor, low-tech physical tweaks is an absolute game-changer.
But first, to really understand why this matters, we need to ground ourselves in the sheer scale of the problem. 203.8 million. That's a massive number. That is the exact number of tons of carbon dioxide emitted by the Brazilian transport sector in the year 2021 alone. It's honestly staggering. The way we move around our cities is just fundamentally linked to the air we breathe and the climate challenges we're all facing.
Now, usually when we talk about reducing those emissions, the immediate go-to answer is public transport. And in medium to large cities, particularly in places like Brazil, public transport overwhelmingly means buses. Just look at this. A massive 85.7% of public transport journeys rely on them. They are the absolute workhorses of urban mobility. They do the heavy lifting of getting people to work, to school, and back home. But this brings us to a really interesting conflict.
Which leads us to Section 1. The public transport paradox.
So here is the paradox we have to wrestle with. If public transport is supposed to be the sustainable, eco-friendly alternative to everyone just driving their own cars, why is it still polluting so much? Well, the reality is that the vast majority of these urban bus fleets, they aren't electric yet. They still run on dirty fossil fuels, specifically diesel. Now, sure, one bus carrying 50 people is way better than 50 individual cars on the road, no question. But those diesel engines are still pumping out particulate matter, carbon monoxide, and nitrogen oxides right into our neighborhoods. They are totally essential, but their environmental footprint is still just way too heavy.
Let's move on to Section 2, the hidden emissions culprit.
To actually fix this, we need to look under the hood at the mechanics of driving itself. Fuel consumption is incredibly complex. It's not just about the engine you have. It's a whole mix of things like vehicle weight, weather conditions, traffic jams, but I really want to focus heavily on two absolutely critical factors for our explainer today. First, road gradient, meaning the literal hills and slopes of a city. And second, driver conduct. Basically, how a human being actually drives the vehicle interacts directly with the physical geometry of the road.
Try to ground this in your own experience for a second. Think about the sound and the whole-body shudder of a heavy diesel bus. Imagine that bus stopped right in the middle of a steep hill just to pick up passengers. When it's time to get moving again, the driver has to absolutely roar the engine, demanding massive torque to rapidly accelerate from a dead stop up that incline. And why? Often just to meet a rigid, somewhat arbitrary timetable. Research shows that this rapid acceleration on elevated areas is the absolute enemy of fuel efficiency. It creates massive, intense spikes in toxic emissions right where people are standing on the sidewalk. So how do we solve this? Well, enter the tech-powered hero of our story.
Welcome to Section 3, Smart Sensors and IoT.
To fix this physical problem on the streets, we first need perfect data. Check out this modular smart sensor array. It's actually designed to be mounted right on the top rear of a bus. Now you might be wondering, why the top rear? It's because aerodynamic airflow naturally curves around the back of the bus, which allows this device to perfectly capture the breathing of the city. It's brilliant. It's got a GPS module tracking altitude, speed, and location. It has a climate module for temperature and humidity. And crucially, it has a gas module that is literally sniffing the air for CO2, carbon monoxide, and nitrogen oxides in real time. But of course, gathering all that data is really only half the battle. How does the moving bus actually tell the city's servers what it's seeing? It uses something called LoRaWAN. This is a low-power, wide-area network technology. It's honestly perfect for urban environments because it provides a continuous stream of real-time environmental data and it punches right through buildings and concrete obstacles without draining massive amounts of power. The bus essentially becomes a roaming environmental laboratory. And this brings us to the ultimate aha moment of our explainer, which is Section 4, Optimizing the bus route.
So, what does all this sophisticated, real-time data actually tell us to do? Well, it brilliantly illustrates the solution. Just notice the stark difference between these two routes. On the top, Route A, is your traditional bus route. See those heavy, dark pollution clouds clustered around the stops? That right there is our heavy diesel bus struggling up hills, starting and stopping. Now look at the bottom, Route B. This is the optimized route. The pollution clouds are drastically reduced, and the driving looks incredibly smooth.
The really crucial point is how they achieved Route B.
it is such an elegant fix. The data revealed that instead of forcing drivers to hit rigid, traditional timetables, which, remember, forces that rapid, polluting acceleration, cities can use fluid time windows. By calculating a least polluting speed, drivers can coast much more naturally. But here is the real physical genius of it. The data tells city planners exactly which bus stops are causing the most engine strain. By physically relocating a bus stop just 20 meters off a steep hill and onto flat ground, you instantly eliminate that massive spike in acceleration pollution.
Which brings us to our final section. Section 5, Small Tweaks, Massive Impact. I really want you to think about this quote directly from the research. Ecological driving can serve as an alternative for reducing pollutant emissions without requiring vehicle replacement. I want you to emphasize that last part in your mind. This is the true beauty of this solution. Municipalities do not need to wait 10 years and spend billions of dollars replacing entire fleets with electric buses before they can start seeing cleaner air. They can make massive, highly targeted impacts right now using their existing diesel fleets, simply by changing how and where those buses drive.
So, if you are a city planner or a municipal manager watching this, here's the clear, actionable framework. Step 1, collect real-world data using those roof-mounted IoT sensors. Step 2, pre-process that data, filtering out anomalies like rainy days or traffic accidents so you get a really clear baseline. Step 3, run the model to find the absolute least polluting speed for that specific route. And Step 4, change the physical world. Adjust the timetables to allow for that eco speed, and move those problematic bus stops off the steep inclines.
It's just a perfect marriage of high-tech data collection and low-tech, practical implementation. By just moving a signpost 20 meters down the road, you can literally change the air quality for an entire neighborhood. It really makes you look at your own city differently, doesn't it? It leaves me wondering, what other everyday physical systems around us are just waiting for an elegant, smart, data-driven tweak? Thank you so much for joining me for this explainer, and definitely keep looking for those smart solutions in your own city.